Sorry about that break in the video. So, I described to you what my project was, and I'm going to go through the script. So the only variable that was public was this text field, and the only reason for that is because I end up wanting to connect it to another object later. So it's super easy to expose it and connect it. Everything else you'll notice are private, and if I just put a space here. These are serialized fields, so they're private floats. We have distance. I'm setting it to default, assigning it to 5 units or 5 meters. And then we have this distance change, which it just gets declared. It doesn't get assigned. So both these are private, but since they're on the same line, you could declare two variables at once with a comma. One actually gets assigned, one does not. These two variables are serialized field. That is why they are both available for me to change in the inspector, but other scripts cannot access them. And notice how they're both declared in one line, and they both become serialized fields because they're on the same line. So some of the variables I pulled out of the update loop. So you might have been doing like game object primitive in the loop. And since we're making use this variable over and over again, so for example, vector3 click position, I have made them private, and I put them up top. I made them global so that they're accessible to any other method on this script. But more importantly, they only need to be created in memory once, and they just exist. They stay alive for the extent of that the app is running. And when the app is closed, they are destroyed and memory is released. But if they're declared here in the update loop, they're constantly being created and destroyed, which can slow down performance. So just know that any variable that I'm using, everything except here, like I could even go and move this array up, but I missed that one. Just know that this is what my script looks like right now, and I've tried to move most of the variables. Yep, they all look good. They're all up here. So I've got some ints, I've got this game object, I got some floats, I got this text which I'm connecting to a UI element I'll get into later. Some more floats, so vector3, a bool, a true or false variable. And let's get into it. So we have our update loop. Now notice here I got a little change. I got two if statements. So I'm actually, this one here is checking left click or hold. So get mouse button down, remember that is only true when you first click, and get mouse button is only true while you're holding down, not when you're first clicking or releasing. And the input that we're checking, 0 is left click, 1 is right click, 2 is middle click. So this is basically, I'm only checking if left input happens, left click. And the functionality we're doing here is I'm only deleting. So I'll get into the larger structure of this script, but know that I am only checking for any colliders out in the virtual world that my mouse position is over when the user left clicks or holds. This is how I'm initiating that erasing my objects. All right, so I'm going to get into it. This sentence is getting a little bit long. It's coming off there. I'm just going to bring it down there, and so that we have 2 lines of comments, easier to read. So this section right here is just using left click, and it's checking for colliders out in the world space, which our objects are being spawned. If it hits them, it's going to destroy them. But since this actually doesn't happen until this happens, because you have to create something first, I'm going to go over this part first. All right. So this is saying if right click or right hold. Notice that there's a 1 now, not a 0. So this is checking for right click or hold, right? Now, I'm just saying click position equals this. Okay, click position is a vector3, and if I double click it, it highlights it up here. It's already a vector3, I don't need to declare it again. I'm assigning it. I'm in my update loop. My update loop is just checking for user input. This user input right here that I'm interested in is my right click, and I'm just arbitrarily assigning that to my create. And actually later on I should probably in my user input say right click to create, left click to erase, or right click to paint, left click to erase, or what have you. But if you want to switch around, you want to do left click for paint and right click to erase, you do all by means, you're writing your own scripts. So vector 3 is going to be equal to something. This is the screen to world point function method. This was the first input script that I covered with you. I'm going to use it for this situation. I find it handy. Read in that mouse input, and we're just going to cast it out. So that mouse input gives me the X and Y, and I want to cast out in the Z. Where should I be growing this object a distance from the camera, right? So this distance, we're doing this in class. This is a float that I'm going to mess around with. I can make it available, and I can even change it real time, which some of you are doing. In this situation, it's always being drawn out at 5 units. Now, this is a switch statement. This is similar to an if statement. So I could have just said if, I'm reading in this shape variable here. So if I come up here, it's an integer. By default, I set it equal to 0. So I actually assign it so it's equal to something. So I should talk about some default values for a second. When you declare something and you don't assign it something, it'll get whatever its default value is. So if I create a bool and I do not assign it to anything, its default value is false. So if I do not say equals true, this will by default equal false. A float by default 0.0, an integer by default is 0. So I didn't really need to declare this, or assign it, I should say, but I did. I wanted to make sure that this integer is equal to 0 when we first start. So when we first start, even if the user is not interacting with my interface or nothing, this is a 0. We go into a switch, so it evaluates each case what this variable is. So it can only be 0, 1, or 2. And you can do an if statement too. You say if shape equals 1, or if shape equals 0, do this. We're going to create a sphere. If shape equals 1, do that. If shape equals 2, do this. But this is what a switch statement is. And when your if statements get a little more complicated and they keep growing and growing, sometimes it's useful to use another decision statement called a switch statement. So we're switching what we're doing based on what our input is, which is this integer called shape. So if shape is 0, we do this, and we break, meaning we break out of our statement, meaning we do not evaluate more. We are done. Case 0 is true for this situation, and we're going to create a sphere, and then put this variable reference connected to that sphere, and we're going to break out, we're going to continue on. If shape equals 1, we're going to create a cube, connect this reference to it, break out, continue on, and so on with the cylinder. So what happens after we evaluate what shape number it is, well, we're going to change the scale, which we went over, randomizing the scale. We're going to place the object. So wherever the click position is, that's where the object's going to be. And then we're going to change the color of it. In this case, it's just a randomness from 0. And in class, I went from 0 to 1, 0 to 1, 0 to 1. But now I have a variable here called red, green, blue. By default, I have it set to 1. So if the user doesn't mess around with the interface, it's always just going to have a 0 to 1 randomness on all the colors, which is what we're starting with. So for example, if we wanted to then expose scale into the user interface, instead of hard coding the values, we're going to replace these with variables and then connect those variables to our user interface. But for now, I just did the color, so that's why there's variables here, because I'm going to mess with them real time. So this is new to you. I'm taking the actual, making the parent of this sphere, cube, cylinder, whatever this primitive that I'm spawning, I'm making its parent this transform. So this corresponds to this script. This script is a component here. So this instance of this script, which is living on my click manager, that's what this is in reference to. So we're saying this dot transform. So that means go. That means shorthand for go get component. That means the transform. So as I click play, I'll show you again parents and childs, which you should have gotten a little used to. So I'm going to turn off time destroy so that I can just click a few. And so here's the spheres. These are the objects I'm spawning. They live underneath the click detector. This is parent-child, so if I close it up, it lives underneath here. Let me close up my canvas too. This is all my UI stuff, which their parent is the canvas. So it's a good way to clean up and organize. You see I can shrink it down, what have you. But it's also a good way to know where these objects are. So later on, I can just say delete them all. Sure thing, I know where they live. They all live underneath the click detector. So this is what's called parent and child. Essentially like a grouping or a hierarchy. Game objects are objects living within objects. And they deal with the transform. This is just a convention. So basically you say, okay, I created this primitive. Go get me its transform. I'm going to assign its parent to, well, go find where this script is living, which is just, it's a script called click position manager, sprint1 living on the click position manager. Go find its transform and assign it as the parent to the sphere or the cylinder or the cube. And that's why when I paint stuff, it's finding the script that's growing it, saying, hey, go get its transform. Okay, that's this object's transform. Place all these instantiated objects within it. So the great thing with that is not only is it's organized, and I know where they are, so that I can click destroy all, it deletes them all, which we'll get to that function later. So I have this if statement saying if time destroy is on, well, then we're going to destroy the primitive within 3 seconds. So time destroy is on. I come up here, the private bool called time destroy is on equals true. So when it's true, time destroy option is on, and when it's false, it's not on. So by default, it's true. This is why I'm assigning it to true, because we are setting up the default behavior of the app to have a timed destruction or erasure of our content with 3 seconds. And if you want, you can make that a variable and expose it. So by default, this is true. We go in and do this, but I leave it open to the user if they don't want to do that through the interface. Now, mouse position. I have to get into how this string is being built. But notice that the mouse position.text, we're assigning it to where our current input.mouseposition.x, our x and our y, and we're using the to string to print out this float. Then you can specify how many decimals. So if you want 2, like a dot, if you want 7 dot, 23, 7.23, this would have 2 there for 2 decimal places. I don't want decimal places. As you notice up here, we're just dealing with whole numbers. When I click play, it's just some standard input, and then there's the numbers that get updated. So this is evaluated outside of our if statements. It's sitting in our update loop, meaning it's being updated all the time, independent if this statement is true or if this if statement is true. And then we have a bunch of functions, public functions that our user interface elements can change our variables with, which again, these variables are private, and I'm changing them through a method very similar to a setter that we talked about in class. And I will go through these. So before I get to erasing, let's work through here, right? And now we have this switch statement. So this should be familiar to you, this if statement. Now we're talking about this switch, or you can just do it with a series of if statements, whatever you're comfortable with. But that allows me to introduce the UI. So I'm going to just turn off the join canvas for a second to make it one less thing to look at while we go over this. So when you go game object, UI, whatever you create, to start off with, it'll be placed underneath a canvas. You just leave everything as default. It's already set the screen space. I already went over this, and I assigned you Unity videos to go over this. Notice as I move this left or right, my UI elements kind of stay in place. That's very important to me, and I'll show you that's an important aspect. But let's start going through this. So we have here a text element, which is this. If I turn it on and off, if you just say game object, UI, text, and then I do the move tool, and if I just kind of move it in here, you're going to position it wherever you want. Let's just say I want some text over here. Let's just say it's left justified. It's sitting on our left, right? And then you enter something, and oh, this is my name, my class. Now notice this is something interesting. I just did a second line here, right? And my name showed up, my class did not. And if I zoom in, this is the kind of the size of the text box. Well, actually the height needs to be opened up. See that? And all your text gets shown in. So if I say my class, my section, notice how it's not high enough. So we have height that we're talking about. Now we're dealing with this rect transform. So this transform used to regular transform. This is a rectangle transform or a 2D transform, very specific to the user interface. It's not in a 3D world. And it has to deal a lot with aligning and making sure things are anchored or kind of held in place. So that's why it has this very special transform. So notice as I lower down the width, eventually the stuff starts getting cut off. So what you want to do is after you finish writing out your text, kind of align your width and height that makes the most sense to it. Notice you can do other things. You can align your text, center it, what have you. That's some paragraph options, similar to a Word editor. So now we were just messing with width and height. Notice I got the move tool going. That's this up here. And I'm moving it with the square, this blue square, which lets me go left and right and up and down at the same time. And notice the position, X and Y are moving. So position Z doesn't make sense. We're not having our elements in different depths because they all supposed to live on this like flat plane of a user interface. But notice you get it really happy. Say I'm positioning it, and I opened up its width and height. Now we talked about and used all of the positions on all of the width and height, so you should be familiar with that. So what happens if I move the size of my window here? I should tell you that we're not doing free aspect. You want to go down to 600 by 9. We're doing this 960 by 600 because this is what it's going to look like in your window on the web player. So I went over kind of these dimensions in the WebGL one. But if this 960 by 600 is not, just click that plus, add 960 by 600. Then you have this aspect ratio to work with. You know that this is what it's going to look like on the web. What you see is what you get. It's going to look like that. So notice that this is off. Let me move it in. And as I move it around, it works pretty well. But as you shrink, you notice how everything is shrinking down, but it's kind of getting pushed off. All right, so that is now I can click here. And we have anchor presets. We have these, meaning where should it be like connected to in our canvas. So since this is living on the left, we want to anchor it on the left. So if I'm going to click this left anchor real quick and show you now that it kind of moves correctly left and right. It kind of sticks where it's supposed to when it's on the left, right, or the horizontal, but maybe it's not moving with everything up and down or the vertical correctly. So we picked the right side. So if I didn't pick the right side, say, oh, this thing should be anchored on the right. Notice how it moves off. It's not correct because it's not sitting on the right side. Although if I did move it over here, and I do want this text on the right side of my user interface, then anchoring it on the right is correct behavior. And as you can see, it stays correctly. So let's say I want my information to be up here underneath my dropdown. Well, this would be the right top. See how the dot is up here? So first we pick, okay, left, right, which side of the UI should this be anchored? If it's in the middle, dead center middle, then it makes sense to anchor it in the center, which is the default behavior, and it should keep itself centered up, right? But say I want to move it to the right, and I want to move it with my little top grouping. So you have to think about corner parts. So this part is the top right. I'm going to say, nope, you should stay up with the top right. See how he kind of sits there with the drop down correctly. Everything looks good. If I did right and bottom, notice how he stays on the right side. That's good, but he moves up and down too much. He doesn't stick in his vertical location. So anyway, for this situation, it's top and right. But notice how my name I put in the top middle. That's why I have this anchor at the top center. That's why he kind of stays anchored up in the center and at the top as we move around. So I'm going to delete that. That is how I made my text. And it's got no code connected to it. It's just a label. It's static information, stationary. It just, I'm testing my spacing of my UI and it sits good. It sits well. We're good to go. All right, next I'm going to introduce the drop down just because the switch statement here is connected to it, so why not? So that's game object UI drop down. All right, so when you create a drop down and you move it in, it looks something like this. And you have three options by default. You can add more, you can add less, but at the end of the day, however many options you want in your drop down, you write them out and you create as many options and then you place it. So an example, if I want it at the bottom to the right, I would say, okay, my position is correct, my width and height of it is correct, and I'm going to connect the anchor at the bottom right. So then I test, and yep, he stays at the bottom right. We're good to go. I could say, oh, you know what? Everything is great, but he's a little wide. He's kind of using up a lot of space. So I could shrink it down because this is the size of the name in it, option A, sure. So that's how I got here. Notice I'm naming stuff too. So UI dropdown, just says dropdown. If I create dropdown again, UI dropdown 1. You start building your UI, things don't not, it's hard to find. So after positioning it with width and height, filling out text, notice I write project info. I know that, oh, this text relates to my project. Dropdown, I'm going to call it dropdown primitive because the list on it is going to be primitive. So I just replaced it with sphere, cube, and cylinder. In fact, my width is a little high maybe. I'll shrink it up. And since I did that, I can move it over a little bit more. All right. Since we are good to go, in this stuff, this by default will be empty. So let's, I'm just going to do game object UI dropdown and just create another empty dropdown. And notice that there's a bunch of stuff underneath it. Don't worry about it. A lot of it's been pre-built for you. Sometimes there's some of them I'm going to show you when you want to go in. Just know that you can open it up. There's other game objects. Just worry about filling your options. And now we have this on value changed. We're going to read in integers. So it's kind of telling you what information it's going to want to send out when the information gets changed. So we're going to add the plus sign because we want to connect a method to it. Right? And I'm going to delete this now because I'm going to go back to my dropdown. And notice I have it clicked to my click detector, and it's using this change shape method. So let's go over that. So at this point, know that a dropdown feeds out integers 1, 2, 3, or 0, 1, 2, I should say. 0, 1, 2. I have 3 options. So whatever option you select, that's the number that'll come through. So it's important to say, oh, this have your memorization of your numbers. So here I have the first one, or 0 is sphere. Second one, or 1, is cube. Third in our list is cylinder, or the second, which will be number 2. So I need to create a method. In this case, it's this one. Public void change shape. It's going to expect an integer because the dropdown told me it's going to be sending out integers. And I'm going to call that integer temp shape. It's just a temporary integer variable. It's going to exist for a little bit of time, and then we don't care. Well, I'm going to take that temp shape, and I'm going to set my shape to it. So what is shape? I'm going to double click. It's an integer. By default, we set it to 0. And by just the system I'm setting up, 0 means a sphere. Or it can mean whatever prefab you have, multiple prefabs. So that is why I have an integer called shape, and I have a switch statement or a series of if statements that read in or expect a 0, a 1, or a 2. And they expect a 0 to be a sphere, a 1 to be a cube, and a 2 to be a cylinder. The whole reason for that system is because I created this dropdown that said option 0 is going to be sphere, option 1 the user is going to know as cube, option 2 the user is going to know as cylinder. And it's going to send these integers here. So I have this public void change shape reads an integer. It's going to change my private integer called shape and change the integer value on that. So the next time we run through the update loop, if the user is clicking the right mouse button, it's going to say, oh, okay, which shape? And if the user changed the dropdown, say he changed it to cube, then it's going to be set, shape is going to be set to 1. It'll evaluate here, which means we're going to create a cube primitive, and then we're going to do all our modifications to that primitive and possibly do a timed destroy on it. So once we create this little method here, change shape, I'm going to empty out this on value changed. So now it's empty, right? I'm going to say, okay, create this drop down. It's got sphere, cube, cylinder. It's going to send in integers. I created this little method on my click detector, which I'm going to drag into there. And it says, okay, what method on the click detector do you want to use? So it's a little out of bounds. I'll move my window a little bit. And it says, okay, I know I've got the click detector object, frame object connected. I know that this is the script, this click position manager sprint one. And here it is, dynamic int, change shape. Okay, this is the function name, change shape. And it's saying it reads in dynamic int. This method, this function, reads in dynamic integers, which means it can read in different types of integers, which is because I created that way with an input here of temp shape. So every time we select something different, it'll send this integer to this method on my click detector. That method, all it's doing is changing the integer called shape. That integer, I'm doing a switch statement on to tell me which primitive should I be creating. And that is the whole essence of this dropdown up here. This allows me to draw spheres. Say, no, I don't want to draw a sphere. Draw a cube or draw a cylinder. And again, you can connect whatever you want, whatever your prefabs are. This is how a dropdown works. This is how I connected it to my click detector. And I connected it down here. And it's a little method, very simple method. Right here, changing an integer, and that integer is just evaluating to different primitives through this switch statement when a right click happens. That is the essence over and over again of the user input of each of these interface elements. So what's next? Let me just move on down here. So local scale is kind of hard coded, 0 to 1, doesn't do anything fancy. We have color. Okay, color, red, green, blue. We have 3 floats separate. By default, they're set to 1, 1, 1. Here they are connected to our red randomness, green randomness, blue randomness. Red, green, blue as our max value up to 100% of that color. So this is why I have 3, down here, click the wrong ones. This is why I have 3 methods, public. All they do is read in a float, some type of temp float, and set my red, my green float, my blue float to that. So change red, we change red float. Change green, we're going to change the green float. Change blue, we're going to change the blue float. These floats are just being used here as our max evaluation of our random range. So as we lower the slider for red, we can only pick between 0 and 1. As we lower it, maybe 0 to 0.7, 0 to 0.5. And as we drag it all the way down, we only get a random number between 0 and 0 or 0. So how do we create these sliders? Game object, UI slider. And as I move it over, this is the slider. You can scale it if it's too big. That's what the scaling here, part of our rect transform. So we covered position, X, Y. We covered width and height. We covered where to make sure we're anchored on which part of our user interface. And we also mess around with scaling if we care to. So if we do the scale button, which is this over here, or the R key, we can scale it up or down to whatever makes sense for us. We can ignore all this. What we're super interested in is the min value, the max value, what the default value should be. And what method are we calling when the user messes around with the slider? So in this case, we're doing 0 to 1, going from 0% to 100% or 1 of a float, red, green, blue. By default, we're starting at 1. So we go from 0 to 1, and we're defaulting at 1. Notice as I put 1 in, the slider moves. So you can actually move the slider here. This shows you that the different value ranges between 0 and 1 because that's our min and max. And I'm going to place it at 1 and say, okay, I need to connect it to a method now. And I just added plus. What's the method? Well, on my click detector script, I created these. So I'm going to create 3 sliders, all from 0 to 1, defaulting at 1. And I'm going to name one slider red, green, blue, and connect it to each of these methods. I got to talk about the label here next to it. So I take the click detector, I connect it, and I say, oh, okay. And it actually reads in which methods on this script, on this game object, are expecting in floats. And it sees my change blue, change green, change red. So, in addition to this slider, what I did was to get these little labels. I like how there's like a little box around them. So I actually used a button by default. You can create a text too, and it doesn't have a background, but if you wanted to, you create a button. And what I did was, if I open up the slider, you can see I just popped the button underneath it. So I'm using this parent-child situation. So if I pop the button underneath the slider and zero out its position, now I can mess around with it, say the width of it, name it. Let's just say, okay, this is meant to be red. So before I change the name of it, let me change the width and the position X. So now it's sitting right next to my slider, but it's a child of the slider. So the huge benefit of that is I can move the slider and the button comes along for a ride. So I don't need to worry about kind of moving one and then moving the other. It's really annoying. But the thing is, the button is clickable by default, right? I want to turn that off. Or you could actually just turn off its function as a button. I could just remove the component, turn it off or remove it. It's just an image. I don't want it to be interactable. Then I go down underneath the button, there's text, and I code, okay, this is going to be red. And I just filled out the text, and I scaled it and positioned it. And now I have a nice little label that has a little background, very easy to read. And so I kind of repurposed the button, even though the button by default was interactable. It just had a component on it called button, and I just removed it or turned it off. So now I have a slider and a label. So the label tells the user, oh, this is meant to mess around with the red. Perfect. So if this slider is red, let me name it red so I know what this slider is. And it's meant to then call the change red method on our click detector script on the click detector object. Then if I shrink down, and so all that functionality is underneath this slider red. Move around, I can position it. Okay, I want it in the bottom right. If you want it in the bottom right, that means my anchor needs to be in the bottom right. It changes some numbers, don't worry about it. It's still in its same location. And as I move this back and forth, it sits down there. Awesome. So I made a slider. All you gotta do now is just duplicate it. And say red goes here. I'm gonna move this one up and then I'll call it green. All right, so I say slider green. And it's still 0 to 1, defaulting at 1. It's just calling the green, change green methods, just calling a different method. Awesome, we're good to go. Its label is out of date. We call that label green. And shrink that back down, duplicate, call this one blue. Move that down. And then I'll just change the label since that was the first thing I was thinking of. And all this is the same, and it's just calling blue. Now we've got 3 sliders, and they're changing the color of the objects I'm spawning. All right. So I happen to have 2 sets of sliders right now. I'm going to unclick play and get rid of them. Click play. So now it's randomizing between all the colors. Let's get rid of red. Now it's randomizing between just green and blue. Get rid of this. Now it's just randomizing between green. And I already explained to you how the colors work. That's why we're getting from black to green. Because black means it has 0 brightness on it. All right. So now we've described how to spawn different primitives, or prefabs. We've described how to change the color range. And let's move on. So we just covered titles, our text. We've covered drop downs. We've covered sliders. We've covered how to convert buttons to text if you choose to have a nice little background to it. Just not make it interactive. Let's move on. Switch. Okay, I went over randomizing the color. This happens no matter what. I went over what parenting and childing is and then I showed you how to do this. So this is interesting. Let's switch the timer. Let's do a toggle on the bool here. Let's say this is true and it could be sometimes false and it's up to the user. That's what this time destroy is. So since I named everything nice, I can jump into it to toggle, game object, UI, toggle. Pop this over. So toggle, I open it up. By default, there's a little label here, so you can say whatever turns it on and off. In this case, I'm labeling it my time destroy, whether you want it off, but you give it your title, whatever this feature name is. This is where you put it in the label. Toggle, whatever the feature is, you label it with the feature name. Now, for a toggle, it's all done for us. All we have to say is, okay, what method is it messing around with? Click plus sign, we're going to add a method. Notice on value changed, it must read in a Boolean. So that is why I have a private bool called time destroy is on. By default, set it to true. So whenever we're doing user input, this is valuing the true and we destroy. But if we want to, here, we have a public void toggle timed destroy with a bool. I just called it timer, you call it whatever. We feed in that bool and then we set our time destroyed is on to whatever this incoming bool is. This time destroyed is on is used up here. So the user can switch this on or off, true or false, to whether your objects get destroyed within 3 seconds. And if you care to, you can even expose this out through a variable to the user interface. They can change the time. So, click detector is our object that we're manipulating, and we must find the function. And there's a lot of bools are very commonly used. You see a lot, but dynamic bool. What functions expect a dynamic bool? This is one I made. Toggle time destroy. So when this is clicked off, that bool becomes false, and when it's clicked back on, it's true. Now it's important to note that you can set its default state. So if I say no, by default it's off. When I click play, notice it's off. And then you click it on and off, and it's updating here. So whatever bool this is interacting with, by default, this must be set to whatever that bool is. So in my script, time destroy is on. By default is set to true. So this needs to line up with it. So I need to make sure it is on. It's just not, I click play again, it'll reset itself. It's just, it doesn't real-time update. But there we go. So I position it, scale it, get rid of the width, what have you, and set its anchored location. And then we have another feature. So I'll destroy that. That feature again, I'll demonstrate. Paint. Wow, that looks great. And after 3 seconds, it's gone. And then as a user, I'm like, nope, I want a new feature. And I'm going to paint. And now it's not destroying, it's just staying there. All right. So let's talk about, and actually, watch this. I can turn on time destroy, paint something else, and it'll destroy that. Time destroys on, it'll destroy that, and say, nope, this paint stroke is going to live forever. And now it's living forever because I turned off time destroy. So see how this can change your brush strokes or your features real time. So that's great. Now we can talk about destroy all, which I just clicked. You see it works. So for even stuff that's there forever, or even stuff that is set to be destroyed within 3 seconds, it'll work no matter what. So destroy all is probably the simplest one, and I'm covering it last, so that's interesting. But game object UI, it's a button. A button just has a graphic, and if you click it, it just runs a method. Notice how nothing is put in. It's not expecting an integer, it's not expecting a float, it's not expecting a boolean. It just runs a method. And then you click here to populate what method you want to run. You want to run multiple ones, you can do that too. But I'm just running one method. So you got to label the button, whatever the feature is. And again, you're going to go to the button and you're going to resize it, and you're going to position it, and you're going to anchor it, and then you're good to go. And this time it is a interactable button. I'm not removing this and using it just as a background, just as a static object. So let me move down here. Here we go. Public void, destroy objects. So for each, we're going to a for loop here. This is something new. We'll probably cover this more next week. For loops and for each loops. But this is a simple way of saying for every transform or every game object as a transform, in this transform, we're going to destroy that child transform, that child game object. So this is why I'm putting all of our spawned objects as children of click position manager. So it's very simple to find them and destroy them. So that is why I'm doing this. Everything I'm spawning, I'm finding its transform, I'm making its parent this transform, this, which is the click manager. So find the click manager, which is myself, pretty easy to find. Make this the parent of everything. That's why everything spawns underneath it. And so when I do destroy objects, I use this for each loop, which is a very simplified for loop. We're into for loops next week. I don't even need to know how many objects are in here. Doesn't matter. We're spawning a whole bunch. The list gets huge. What happens is we look within our transform. We are the click position manager. We look at our transform. Remember, transforms are how we look through our parents and our children game objects. And then we look at each child transform. So this is saying for each, I'm declaring a variable called child for each iteration of this for each loop, for each children transform that are in our transform. Take this child, take its game object, its whole entire game object of this child, this spawned child object, and destroy it for each and every transform that was a child of our click position. And if it's a child, I know for a fact it's one of my paint strokes. So as I paint, you see it's underneath click detector. These are its children. No matter what I'm spawning, it's a child of click detector. I know that information for a fact. So I can say go through all the children and destroy that each and every one of them. For each child transform in our transform, this transform, destroy that child game object. So this is a function that reads in, no input, called destroy objects. That function is called, I'm going to delete this button because I was just showing you how I built my button destroy all. That's the text for it. Here's the button for it. On click, call the destroy objects method on our click detector. I'm not reading in a bool, not reading in int, not a float. Just call this method called destroy objects. Destroy objects just does the same thing. Look at all of its children and destroy them all. That's it. That's this destroy all button. So I went through the drop down, I went through the title, I went through this toggle, I went through this button, I went through this slider. Each slider having a button, but that button is deactivated, and I'm just really using it as text. So I went through all this except mouse position. So I went through all these little methods. Oh, and I still have to go through the right click. Okay. So let me save that for last. So this mouse position dot text, which lives outside of our if statements, it lives in the update loop, so it's evaluated all the time. I wish to change the text on this here. Even though I started off as a button, I turned off the button, as you can see here. It doesn't do anything. In fact, I can just remove the component. The real trick of it is there's a text object. This is the default text. It's positioned and sized well with the default text, because I know this is about the amount of space that I'm going to take up. And this is a default text on it. And if you notice, I did a public text called mouse position, and all I did was drag this onto that, saying this is the text that I'm referencing. So this public text, which needs the UniEngine.ui to use this type of variable, I called it mouse position. What am I doing? Mouse position, grab its text element. So this game object, this text component has a field or a variable called text. So mouse position is really a component, a data structure of type text, which is really this component right here, this whole component, this whole UI text component. This is what I'm getting a reference to. And dot the text field on it, the data variable. So mouse position dot text equals, and I'm filling in some strings. I'm saying every update loop I want to fill out mouse position x colon space, feed me in the x position from my mouse input, and toString it, meaning I don't want the raw information. Use a toString. All these data variables have a toString method that helps you clean up the text version of it. And I'm saying truncate off the decimals. Give me just those first, the integer side, and truncate off all this decimal side. Concatenating more string. Here's a little string saying comma. Give me the y. Then concatenate it with the mouse position dot y. Give me the toString. Truncate off the decimals. This whole thing evaluates out to look like this. Mouse position x colon, just static. I'm reading in mouse position dot x and truncating off the decimals. And then I'm saying comma y, and then give me mouse position y and truncate off the decimals. That's why these numbers are changing. So notice it looks like we have if I go all the way over, let's say about 680 by 430 is the number of pixels on my screen. that this thing is reading out. That's great. It's still the aspect ratio of this. It's just it's not full screen, and it's showing me how many pixels are being represented. Awesome. And that is how you update text elements dynamically. So, last but not least, left mouse click to erase or delete specific objects. So notice I'm purposely using the screen to world point. I'm not using a raycast method that's looking to hit a collider. So I'm just saying when I'm creating something, find me where the mouse is and add this distance out to it. So find me where the mouse is on the screen, find me the position behind it, say 5 meters out to this virtual world. This is where I'm spawning stuff. It's not dealing with colliders. There's no colliders out there. There's no planes. There's no mathematical planes, nothing. Now I'm reusing one of the other methods I showed you, screen point to ray, which basically says raycast hit if we're hitting something out in our virtual world. Which when I showed you it, it was like, oh, there's just this plane living out there, right? All right. Well, since no plane is living out there, I'm not using it. I'm just using my mouse position and some arbitrary distance to spawn stuff. The only colliders that are out there are the colliders that we created with these primitives, with these prefabs. So when I use this method, I can detect if I'm hitting colliders with a left click or whichever click you prefer. So I'm creating a ray. I'm using the screen point to ray with the mouse position, using a raycast hit. I'm saying if the raycast is hitting something, if this is true, meaning we're hitting a collider, the only colliders out there is things we're creating, destroy the hit.the object. So whatever we're hitting, which is some collider, go get its transform. It happens to be connected with the transform you set to do this. And then from the transform, bump up a level, go to the game object, destroy the whole thing. So this is how I'm left clicking to erase. So draw and erase. Right click, left click. Let me turn off time destroy. Right click, left click, and right click and left click. Create and destroy. Awesome. That is everything you need to know plus some to finish the project.